Hello everyone and welcome to another video demonstration, I guess. And what we're about to see is a little collision take place. I've got both blocks of equal mass colliding at each other, and they are hitting each other with pretty close to pure y velocity meeting pure x velocity. And so let's watch what happens. And so they rebound off, very similar to if you've ever played pool, very similar to that. And so what I did is I made these blocks as elastic as possible. So with this, we can utilize the fact that this is an elastic collision. And so what I did is I took the liberty, I went ahead and plotted the x velocity and y velocity. So here is A, mass A, and this is the block that was coming in from the right. So this is the block with only x velocity. And so here is that x velocity, or x position graph. I didn't make a y position graph just because it's a pretty flat graph, meaning it had no velocity in the y direction. So if you look, here's the x velocity that it has before the collision, and then you notice a pretty steep change in the slope, signifying obviously that a collision took place. So here is the block that was coming in from the top, or the one that only had y velocity. And so we see here's our position versus time graph before the collision, and then here's our position versus time graph after the collision. So here are the slopes for these graphs respectively. And then here we have all of the velocities after the collision. So we have mass B here at the top. It now has an x and y velocity. And mass A also has an x and y velocity. Now, what's important to note is momentum is conserved, but it's also important to note that that applies to all dimensions, which means that momentum is not only conserved in the x dimension, but it's also conserved in the y dimension. And so you can use that information oftentimes to attack multiple choice type problems where you might have something coming in from an angle or something like that. And again, this was an elastic collision. If it had been an inelastic collision, which is what we'll talk about tomorrow, then it would have been a very different outcome. So what I'd like you to do is take a look at these graphs and analyze and see how much momentum is conserved. In other words, is there a big difference between my initial momentum in the x and y as opposed to my final momentum in the x and y? Important note, the two blocks have an equal mass. So good luck.